don't know why my last video cut off, but we'll just pick up kind of where we left off. So we were doing example 6 and drawing a box plot, also sometimes called a box and whisker plot. So in order to draw a box plot, we need to find the upper quartile, the lower quartile, and the median. Those are kind of our boundary points. We also need the extreme values, the largest and the smallest data point. So I already have these in order. So because they're in order, we can go ahead and find that middle value there. That middle value is that median. Then on either side of the median, we're going to kind of block these data points off so that we can find the upper and the lower quartile values. Because remember, they're just the median of this lower set and the median of this upper set. All right, so the middle of these data points, there's 1, 2, 3, 4, 5, 6 of them. So since there's an even number, we know that the middle is going to be the average of these two middle points. So the average, you add them up and divide by 2. So we get 45 as our lower quartile. Same thing over here. The middle is halfway between here. So it's the average of these two. So 85 is our upper quartile. So to plot that, I space these out in increments of 10. So you can see this bar right here coincides with 85. This median was at 70. And then this lower quartile down here falls at 45. So we draw those 3 vertical lines. This extreme point up here is the highest point of 100, and the lowest point is at 20. So with these 3 vertical lines, we can then connect it with what's called the box, right? That's the middle 50% of the data, and it shows you, based on how wide these are, or how long, depending on how you're looking at it, it shows you the spread. So you can see that this part of the data, this 25% is more spread out because this is a longer rectangle than this one. And then we just draw these little whiskers from this upper quartile line all the way to this extreme point, and then from this lower quartile down to that extreme point. And those are the whiskers. So this graph is what's called a box plot or a box and whisker plot. And again, it just shows you how spread out the data is. You can see how this line is longer than this one. It just means that this 25% of the data is more spread out than this 25% of the data. Oh. Talking about outliers. A lot of students mistakenly think that an outlier is an opinion, and it's not. It actually has a mathematical formula associated with it. So if a data point is more than 1.5 times the interquartile range above the upper quartile or below the lower quartile, the value is said to be an outlier. Now, I said this in English, but I'll go ahead and write this in math as well. Okay. So example 7, are there any outliers in the data for example 6? So here's what we're going to find. The upper and lower quartiles, and then this interquartile range, the IQR. That's just the distance between the quartiles. So the lower quartile was 45. We found that from the previous example. The upper quartile is 85. So the difference between these is 40. So here's our formula for outliers. Okay, you can have 2 kinds of outliers. You can either have an upper outlier or you can have a lower outlier, right? These kind of way off kind of values. If a data point is above the upper quartile plus 1.5 times the interquartile range, then it's an outlier. Or if it's below the lower quartile minus 1.5 times the interquartile range. So we're talking about this 1.5 times the interquartile range, that much above the upper or below the lower quartiles being considered outliers. So let's do this computation. So Q3, that upper quartile, was 85 plus 1.5, and the interquartile range was 40. That gives me 145. So are there any data points in example 6 that are above 145? Okay, so we go back and look. Nope, 100 is as high as it goes. So there's no upper outliers. Are there any scores below the lower quartile minus 1.5 times the interquartile range? So if we do that computation of the lower quartile minus 1.5 times the interquartile range, we get negative 15. There's no scores below negative 15. So because there's no scores above 145 or below negative 15, there's no outliers in that data. So these, I highlighted these because that's the formula you're going to use for outliers. And like I said, a lot of students mistakenly think that an outlier is just some data point that's just kind of, oh, that's far enough away that, you know, but no, there is a mathematical formula associated with it. Okay, so are there any outliers in the following data set? So you can see that I have it in order. If it's not in order, you have to put these in order. Why? Because we're going to need things like the upper and lower quartiles. So I put them in order. I found the median, the middle, was halfway between 62 and 62. That's an easy average. It's 62. And then splitting the data into the upper and lower part here, we're going to find those quartiles. So the lower quartile here is the average between 50 and 60. And up here, the upper quartile is the average between 68 and 70. So I got that the median was 62, the lower quartile 55, the upper quartile 69. So the interquartile range is just the difference between these two, which is 14. So if there's any outliers, here's where they're going to be. They're going to be above this formula or below this formula. So again, I highlighted that so that you guys could see the formula that I'm using. It's bugging me that that little bit isn't highlighted. So now that we have these values, let's go ahead and do some plug and chug here. So Q3 plus 1.5 times the interquartile range gave me 90. Are there any data points in this list up here that are above 90? Yes, 100. So 100 is considered an outlier. Okay. Are there any data points below Q1 minus 1.5? I keep emphasizing this minus because one of them's plus and one of them's minus, because the outliers would be above a certain level or below a certain level. So I just want to point out that that formula right there has different signs. So doing a little plug and chug, we get 34. Are there any data points lower than 34 up here? No. So we don't have any lower outliers, but we do have an upper outlier. So when we graph this, we represent any kind of outliers with a little asterisk, because that single point might actually, if you just try to draw a whisker all the way out there, it's going to mislead you. It's going to mislead the data representation, because you're going to think, wow, that whisker is super spread out, when it really isn't, because you have that one lone point out here that doesn't really represent the spread of that 25%. So instead, this upper part of the whisker right here stops at 70, because that was the next highest point. So if there are any outliers, we just denote those with a little whisker. If there are, sorry, a little asterisk here, not the end of the whisker. You could have asterisks at one point, at both endpoints, or neither. Okay, just to be clear there. So you may have one outlier, an upper outlier, a lower, both, or neither. So don't assume that just because you have one that you're going to have the other one. All right, next up is standard deviation. Now, the standard deviation, as the name implies, is just the standard or the average of how far each data point deviates from the mean. All right? So we use this little symbol right here. That's a lowercase sigma, Greek letter sigma. The formula is a hot mess. Okay, it's just a big fat daddy square root of the sum of these differences between each data point and the mean squared divided by n. So this is very much an average, of adding them up and dividing by n. The squared is because some of these points are going to be above the mean, some are going to be below the mean, so you're going to have some of them being negative, so the squared is just to make them all positive. And then you take that square root. This thing, we are not going to use this. We are going to use the calculator. Okay, we are not going through the computations for all this. Now, basically, what the standard deviation tells you is the spread of the data. The mean tells you kind of the middle point, right? The mean and the median and stuff tells you the middle of the data or the average. The standard deviation is going to tell you how much it's spread from that. So a large standard deviation tells you that the data is very much spread out away from the mean. Okay? A small standard deviation means that the data is all huddled up on the mean and just all kind of clustered around it. So let's use the graphing calculator to find the mean and the standard deviation for each one of these. Grab the calculator here. So I already have the answers because I had already recorded this once. Just grab this calculator. All right, so on this calculator, you're going to hit second list. Actually, no, let's not do that. Let's go to stat and let's go to edit. Sorry about that. I didn't want to do the list just yet. So we're going to go to stat and hit enter. So we're going to put these values in for L1 because that's where the calculator looks for the one variable statistics. So we got 18, 19, 20, and I'm just hitting enter each time to enter those in and move to the next number, 26, 28, and 30. So if I go up there and highlight 30, you can see where it says L1 and in parentheses it says 7. That means there's 7 data points. So just a quick check, 1, 2, 3, 4, 5, 6, 7, just to make sure I have them all. Once you get that data in, you're going to have to get out of this edit screen. So we're going to hit second and quit. That's the mode button. Then we're going to hit the stat button. We're going to go over to calculate. And you can see where it says one variable statistics right there at the top. We're going to hit enter once, we'll bring up the command. Enter a second time, we'll execute the command. All right, now we just have to know what we're looking at. Well, the X bar is the mean, so that's 23. That's just the sum, don't worry about it. That's the sum of the squares, don't worry about it. Then we have S of X, don't worry about that. And then we have the little sigma. Both of these are standard deviations. One of them's a sample, one's a population. We're going to use the little sigma one. Then we have n equals 7. And you see a little arrow right there? It means that there's more. So if I hit the down arrow, there's more. We got the minimum value of the data set, the lower quartile, the median, the upper quartile, and the max value. All right, so from this, we get that the mean was 23 and the standard deviation was 4.504. We're going to go through this again with set B. So I would encourage you to pause the video, grab your calculator, and see if you can get these numbers. So let's go back to Stat. We're going to go to Edit. I'm going to clear this list out. Now be careful. Don't hit Delete on the list name. You don't want to delete that list. Okay, you just want to delete the individual items. So you can do that. But just be careful. If you delete that whole list, then you have to delete all of them, and then you have to go back and rename them, and it's a pain for me to talk you through that. Okay, so let's do this again for set B. So that's 0, 1, 10, 20, 20, 50, and 60. So I got those data points in. Oh, you know what? We didn't have to quit out of that. I thought we did. So we'll go to Stat, Calculate, one variable statistics. We'll have to hit Enter twice. This time we get that the mean is again 23. The standard deviation down here is 21.7, what's that, 058, so 706. So these two data sets have the same mean. They both have a mean of 23. But their standard deviations are different. One of them is 4.504 and the other one's 21.706. What does that tell you? Well, this standard deviation being smaller means that these data points are all closer to this mean, right? They're all kind of a little more hugged up on this mean. This, having a standard deviation that's a lot bigger, means that the data points are a lot more spread out from this mean. Okay, so that's what the standard deviation is going to tell you. And we're going to utilize that with the stuff that we're going to do a little bit later in this section with normal distributions and stuff like that is going to come into play. So the stuff that I just did in the calculator, I just wanted to write it up for you. So to put the data points in a list, you hit Stat, Edit, and then you hit Enter. You put the data points in L1 to calculate the mean, the median, the quartiles, the standard deviation. I usually hit Quit. That's just a really good practice to get into because there are some edit screens where you have to get out of them before you can do a calculation. This one didn't happen to be that way, but like I said, it's a good habit to get into. So we can go to Stat, over to Calc, sorry, lost in thought there for a second, and then down to one variable statistics and hit Enter twice. Then here's what you're going to get, all right? Now, I wrote this, ignore the stuff between these, okay? There's going to be a bunch of stuff between this mean and the standard deviation. There's going to be the sum of the squares, and the sample standard deviation. But these are the ones that you're going to need. So you're going to have the mean, you're going to have the standard deviation, then you're going to have the number of data points, the minimum data value, the lower quartile, the median, the upper quartile, and the max. So those are the ones that we're going to utilize. So those are the ones that I labeled. And I just said that between these top two, there's going to be a bunch of other stuff. Just ignore that stuff. All right, well, I hope that helps. And if you have any questions about how to use the calculator, just let me know.